Welcome to G Fun Facts Online, where we uncover the fascinating science shaping our world. Today, we're diving deep, quite literally, beneath our city streets and into the air we breathe. As our cities grow taller and spread wider, an invisible yet profound transformation is happening. It's called urban geochemistry, and it's rewriting the Earth's natural chemical story. This isn't just for scientists in labs. It's about the health of our cities and ultimately our own health. With most of us now living in urban jungles and more joining every day, understanding this is more critical than ever. So, what is this urban footprint we're talking about? Imagine taking a pristine natural landscape and replacing it with a bustling city. Forests vanish, soil gets dug up or paved over, and rivers are redirected into concrete channels. Each action kicks off a chain of chemical changes. The very stuff we build with, concrete, asphalt, metals, plastics, introduces new chemicals. Plus, all our city activities, from factories to driving cars, release a whole host of substances that mix and react with the local geology, water, air, and living things. It's a complete chemical overhaul of nature. What are the main culprits driving these changes? Let's break down the key sources of this urban chemical cocktail. First, industrial and energy emissions. Think factories and power plants, especially those burning fossil fuels. They pump out sulfur dioxide, nitrogen oxides, tiny particles, and heavy metals, which then settle on our soils and into our water. Then there's transportation. Our cars, trucks, and buses are major contributors, releasing nitrogen oxides, carbon monoxide, volatile organic compounds, and more particulate matter. Even tire wear, brake dust, and road surfaces themselves add heavy metals like zinc, copper, and cadmium, plus microplastics, into the mix. Don't forget waste. Landfills, incinerators, and wastewater treatment plants are hotspots for geochemical change. Nasty stuff can leach from landfills, contaminating soil and groundwater with heavy metals and persistent organic pollutants. And even treated wastewater can introduce nutrients, pharmaceuticals, and chemicals from personal care products into our rivers and lakes. The materials we build with also play a part. Weathering concrete can actually change the pH of soil and water. Fresh mortar can be surprisingly alkaline. Metals in buildings corrode and leach into the environment. And because our cities are covered in roads and buildings, rainwater can't soak into the ground as it naturally would. This creates more surface runoff, which acts like a chemical express delivery service, washing pollutants from city surfaces straight into our waterways, often too fast for nature to filter them. This also means less water recharges our precious groundwater. Even our daily lives contribute. Heating our homes, especially with coal or wood, using cleaning products, pesticides in gardens, and even pet waste add to the urban chemical load. So, where do all these chemicals end up, and what's the fallout? The impacts are felt everywhere. Let's start with urban soils. They're often a world away from their natural cousins, disturbed, compacted, and contaminated. Construction can mix up soil layers or replace natural soil entirely with stuff like rubble, ash, plastics, and industrial byproducts. Scientists even have a name for these man-made soils: technosols. Contamination is a big problem, with high levels of heavy metals like lead, zinc, and copper, along with hydrocarbons from oil spills and those pesky microplastics. This can harm soil fertility, soil critters, and even pose risks to us if we grow food in it or breathe in the dust. Interestingly, these soils can also become more alkaline due to cement residues. Even ancient cities show signs of soil contamination from activities like metalworking centuries ago. Now let's look at urban waters. Both surface water, like rivers and lakes, and the groundwater beneath our feet are heavily impacted. Runoff from streets carries a nasty brew of pollutants, heavy metals, nutrients like nitrogen and phosphorus from fertilizers and organic waste, pesticides, PAHs, that's polycyclic aromatic hydrocarbons, nasty stuff from burning things, and pharmaceuticals directly into our water bodies. This can cause algal blooms, suck oxygen out of the water, and poison aquatic life. Urban groundwater is also at risk from leaky sewers, industrial spills, landfills, and polluted surface water seeping down. This chemical soup can make groundwater unusable for drinking. There's even a term, urban stream syndrome, to describe how streams in cities suffer from altered water flow, high contaminant levels, and fewer species. And what about the air we breathe in our cities? The urban atmosphere is often more than just smog. We frequently see high concentrations of particulate matter, those tiny PM 2.5 and PM 10 particles you hear about, nitrogen dioxide, sulfur dioxide, ozone, and volatile organic compounds, often exceeding health guidelines. These come from traffic, industry, and home heating, and can lead to serious respiratory and cardiovascular diseases. Chemical reactions in the city air can also create secondary pollutants, like ground-level ozone, a major component of smog. And what goes up must come down. These atmospheric pollutants eventually deposit onto soils and water, adding to their contamination. Cities also create urban heat islands, making them warmer than surrounding rural areas, which can actually speed up chemical reactions in the atmosphere. Finally, how does this affect life, the urban biosphere? Pollutants in soil, water, and air can be absorbed by plants and animals, accumulating up the food chain. If you're into urban gardening, it's something to be aware of, as crops might take up heavy metals from contaminated soil. Studies have even found that city wildlife, like hedgehogs, can carry a significant load of various pollutants. Ultimately, these chemical changes directly and indirectly impact our health, from breathing problems due to air pollution to potential exposure to toxins through food or water. Urbanization seriously messes with Earth's natural chemical cycles. Take heavy metals, like lead, copper, zinc, and cadmium. They're everywhere in cities, from traffic, industry, and weathering buildings. They stick around for a long time, building up in soils and sediments. We're still dealing with legacy pollution, like lead from old leaded gasoline, in many older urban soils. Nutrients like nitrogen and phosphorus, while vital for life, cause big problems in excess. Wastewater, fertilizers from city parks, and atmospheric deposition overload urban waters, leading to eutrophication. Cities are also huge sources of carbon dioxide from burning fossil fuels, and sealing the soil reduces its ability to store carbon, though urban green spaces can help a bit locally. Then there are organic pollutants, a huge family including PAHs from burning things, PCBs from old industrial uses, pesticides, and pharmaceuticals. Many of these are persistent and toxic. And scientists are now paying close attention to emerging contaminants, things like microplastics, nanoparticles from new technologies, and more pharmaceuticals whose long-term effects in cities are still being figured out. So how do scientists actually study all this? They have some pretty cool tools and techniques. They collect samples of soil, water, air particles, and even plant and animal tissues for detailed chemical analysis in labs, using fancy equipment. They also do geochemical mapping, which means systematically sampling across a city to create maps showing where different chemicals are concentrated. Identifying pollution hotspots. Isotopic tracers are like chemical fingerprints. By analyzing the isotopes of elements like lead, scientists can pinpoint where pollution is coming from, distinguishing it from natural background levels. Remote sensing with satellites and geographic information systems, GIS, helps monitor land use changes, map sealed surfaces, and even spot pollution plumes. Geochemical models can then simulate how these pollutants travel and what happens to them. And there are specific methods to describe and classify those unique urban soils, the technosols. All this means each city develops its own unique urban geochemical footprint. This chemical signature is based on its industrial past, how it's built, the materials used, and how it handles waste. And this footprint doesn't stop at the city limits. It can spread to surrounding ecosystems through the air and rivers. Researchers are working hard to understand and measure these footprints, to see the bigger environmental picture of urbanization. Uncovering a city's chemical story reveals big challenges, but it also shines a light on solutions for a more sustainable future. Cities often battle legacy pollution from old industries, while also facing new threats from emerging contaminants like microplastics. These urban systems are incredibly complex, with countless chemical, physical, and biological processes all interacting. Plus, Comprehensive geochemical data isn't always available, especially for older or rapidly growing cities. But here's the good news. Urban geochemistry gives us the knowledge to build healthier cities. Informed urban planning can design cities to minimize contamination. Think about smarter land use, transportation, and waste management. Green infrastructure, like parks, green roofs, and rain gardens, can help filter pollutants, reduce runoff, and boost biodiversity. Geochemical know-how is also key for cleaning up polluted urban soils and water. Adopting circular economy ideas, reducing waste, recycling, and reusing materials can lighten the chemical load. There is even a concept called urban mining, looking to recover valuable materials from city waste and old infrastructure. And, crucially, raising public awareness and getting people involved is essential for fostering sustainable habits. The geochemistry of our cities is a dynamic, ever-evolving story. As urban areas keep expanding, understanding, managing, and lessening these chemical changes becomes absolutely vital. By digging into the chemical makeup of our urban homes, we uncover their past, diagnose their present health, and, most importantly, lay a more sustainable, geochemically sound foundation for our future. The health of our cities, and everyone living in them, truly depends on recognizing and responsibly managing this intricate, unseen chemical web that city growth sets in motion. That's all the time we have for today on G Fun Facts Online. We hope this peek into the hidden chemical world of our cities has given you something to think about. Join us next time for more fascinating facts. Thanks for listening.